We've already drawn the distinction between ionic compounds and covalent compounds. This dictates how we think about the bonding in the two types of compounds. But we also said there are no molecules in ionic compounds. Why not? We need to drill down a little deeper and think about the difference between an ionic bond and a covalent bond. The simplest way to think about ionic bonds is to consider the interaction of charges. We know from our discussion of Coulomb's law that opposite charges are attracted to one another and would like to come together if they could. This attraction is what we would call an ionic bond. If we look at the structure of sodium chloride from figure 8.19 in the textbook, we see a regular arrangement of sodium ions and chloride ions. The sodium ions are represented by the blue spheres. Well, you might think that sodium should be bigger than chloride since they're both in the third period of the periodic table. Remember that cations are smaller than their corresponding atoms, while anions are larger than their corresponding atoms. The important thing to recognize from this picture is that for a given ion, say the chloride ion at the front, it can interact with several ions of opposite charge. For the front chloride, it interacts with the sodium above, the sodium below, the one to the left, the one to the right, the one behind it, and, if the structure were extended, with another one in front of it. Notice that it doesn't bond with only one sodium ion, but it bonds equally with 6 sodium ions. There are no individual NaCl molecules. Here again is another difference between ionic and covalent compounds, the language. We don't use the term molecule with ionic compounds. With covalent compounds, bonding arises from the sharing of electrons. If you and I were going to make a covalent bond, you could put in one electron, I could put in one electron, and we would share that pair of electrons. That's what we would call a covalent bond. That's what holds atoms together in molecules. But why should that be? To answer that question, we're going to have to think harder about the energy changes that occur when electrons are shared.